This video is sponsored by JLCPCB.com. JLCPCB is the largest PCB manufacturing company located in China. They provide premium quality PCB at an amazingly reasonable price of only $2 for 10 PCBs. You just need to upload your Gerber file and place your order. Now they have also cut down their price for 1 to 6 layer PCBs and stencils. Check out description for more info.
Hello everyone, welcome to the third episode of our ESP32 series. Now after watching this full video, you'll come to know how you can use the HTTP client code in this ESP32 board. You're also going to learn what's the use of Wi-Fi multi-library and how you can use that library in this particular ESP32 board. Then you're also going to learn what's the basic or what's the common difference between the code used on the Node MCU board and the code used in the ESP32 board. What my experience says that most of the codes which were working on the ESP8266 Node MCU board can work on this ESP32 board with a little modification in that particular code. Not a major modification, just a little modification, and most of the codes used in Node MCU can also work on this ESP32 board. So that modification I will let you know in this particular video. And in the end, I will let you know which kind of projects you can make using that HTTP client code. For example, you can make online sensor data monitoring using Thingspeak.com. Secondly, you can make an IoT button using IFTTT. So this is all we are going to learn in this particular video. So let's get started. Let's just jump to the code. We'll open the Arduino. And here is the basic HTTP client code which is available into the files, examples, into the HTTP client, and here is the basic HTTP client. I have commented some of the lines in this particular code, and I will be uploading this particular code which is commented by me and on my GitHub account, whose link is available in the description of this video. So let's just start with this code. This code starts with the include Wi-Fi.h. Now here is the point. As I told in the introduction, I will let you know what's the basic difference in the code used in ESP32 and the code used in the Node MCU board. I have tried, I think, 5 to 10 different type of codes which were used on the Node MCU board and which were working on this ESP32 board also after modifying this particular statement. Okay, so let me just show you the example code for the ESP8266 or Node MCU board. Let's just open that browser, and as I made a series on the Node MCU board also, so let's just see the example, the basic HTTP example code used in the Node MCU board, and then we'll observe the basic difference. Where is the ESP8266 series? Okay, here's the ESP8266 series, and or rather I think I need to open another example which will be much more clear than this particular thing. Let's see this Wi-Fi client basic. So this code is much better than the previous one. So this particular code is used onto the Node MCU board. Now this particular code, exact same code, won't be uploaded into the ESP32 board. There is a single or little modification. Let's just observe it precisely. As you can see, the first line on the code of the Node MCU board says ESP8266 Wi-Fi.h, while the first line of this ESP32 code says Wi-Fi.h. See, I'm not saying all of the codes because I haven't experienced all of the code, but most of the Wi-Fi codes onto the ESP32 board will work after just removing that ESP8266 term before this library. For example, here it is written as Wi-Fi.h, while here it is written as ESP8266 Wi-Fi.h. So we just remove the ESP8266 because this particular ESP8266 Wi-Fi.h library, this particular library particularly works on the ESP8266 boards, while we are using the ESP32 boards, and that board supports the simple Wi-Fi.h library. Let's just observe the second line. Here it is written as ESP8266 Wi-Fi multi.h, while on the ESP32 code it is written as Wi-Fi multi.h. So you observe the difference. They just remove the ESP8266 terms. and they made a new library which is Wi-Fi multi.h, and this library will work on ESP32 board. So this kind of a trick, it's not a trick, it's purely logical, but you can remember it as a trick. Whenever you find a code used in the Node MCU board, and if you are trying to run that or upload that code onto the ESP32 board, just try to remove that ESP8266 term which is used in this declaration of this particular library. So this was the difference, and by using this particular logic or this particular trick, most of the ESP8266 code will run onto the ESP32 board. So note this point. This will definitely help you. If this point really helps you, let me know in the comment below. So moving ahead with the code. Second line says Wi-Fi multi.h. Now I will let you know the details of this particular library further in the code. And the third library, which is HTTP client library, because we are going to use some of the functions used in this particular client library. Okay. Moving ahead, we have Wi-Fi multi, whose instance is again Wi-Fi multi. Now let us read the comment. Declaring Wi-Fi multi instance in Wi-Fi multi class. Okay. This particular Wi-Fi multi is a class, and we are declaring one instance. Now instance is kind of a variable. You can even write your name, like my name is Sachin. I can even write Wi-Fi multi space Sachin, because this is instance are variable. By Wi-Fi class need to be written as it is. Okay, so this is particular kind of variable, and this variable is used is here, everywhere this variable is used. So whatever you're declaring here, you just need to add here also. So this is kind of a variable which is called as instance in this particular Wi-Fi multi class. Okay, moving ahead, we have void setup. Void setup, we are just beginning the serial monitor, nothing else. Then here is a kind of a timer like 4, 3, 2, 1 and connecting. This is also kind of a basic. Now here starts the Wi-Fi multi library. Let's just read the comment. Using Wi-Fi multi, we can add multiple Wi-Fi credentials. I think this particular single line gives answers of the question, what's the purpose of Wi-Fi multi? Still, I will explain you in very brief. Wi-Fi multi dot add AP. Okay, this is a particular object in the class Wi-Fi multi. So Wi-Fi multi an instance dot the object name, which is add AP. Add AP means add access point. Then comes the SSID name and the password. What's the purpose of this particular library? You must have seen we are entering the SSID name and password for only one time in most of the ESP8266 codes, because our ESP8266 requires the Wi-Fi credentials to get connected with the router. So we need to enter at least one host SSID name and password. So let's just write only one name here. SMS 12345 and 8955. Okay, so what's the use of these particular rest of the two Wi-Fi dot add AP? See, in case this particular router, this particular hotspot which I mentioned here fails to connect or fails to work, and there are other routers available in that local area network, so we can add the credentials of that particular router here. So whenever this particular router, the first router fails, the ESP8266 or ESP32 board dynamically connects to the second available router. If second is not available, it will try to connect to the third one. This is kind of to ensure the connectivity of our ESP32 board or our ESP8266 board, to make sure the project is always running regardless of one of the routers shuts down. So this is just for security. We can add multiple access point name and password so that our ESP32 never lose its connectivity. And this is the reason for using this Wi-Fi multi. Okay, so moving ahead, we have the loop. Loop starts with the Wi-Fi multi, again that particular instance dot run equal to WL underscore connected. So this is particular kind of status which resembles or which reveals that ESP32 board is successfully connected to the internet. So when we use this particular function, and if this particular function returns this particular response, that means our ESP32 is connected with the internet. Okay, so we are just providing a condition that if it is connected to internet, then move the code further. Okay, and if it's not connected, I think there is no else function he mentioned here, so it will not do anything if the internet is not connected. So suppose the internet is connected, then we have used this HTTP client class, and again this HTTP instance is declared, which is again a variable. You can use any of the variable here. And http.begin. Now this function is used to request the link. Now this function does the same work which is done by our web browser. In the web browser, we are requesting one link like www.google.com, and that page open up. Okay, so that particular task is done by this particular function, which is called http.begin on an ESP32 board. So we just need to write the particular link inside this http.begin function. Here it is written as example.com/index.html. When we open that page on a web browser, we get something like this. This is example domain. Here it is already mentioned that this particular domain is used for illustrative purposes, for examples of kind of learning the stuff. Okay, so they have used that particular illustrative example or illustrative domain here. Now we will see what happens when ESP32 requests this particular link after uploading this code. Still, let us complete the code. After that, here it is written as serial.print http get. Okay, this particular link is requested using get method. There are different HTTP request methods like get, post, put, etc. So this is kind of a get request applied with this particular link. Okay. So after writing this http.get function, we are requesting this link with the get method. Okay, after that we are getting a response code. Now what this particular line says that if HTTP code is negative, then that's the error. Okay, so if we are getting a response and negative, then that's a kind of error in that particular response. And if it is a non-negative number, then the link is successfully requested. So here we have made a little comparison that HTTP code is greater than 0, which is a non-negative number. If yes, then we are printing the response code we got from that particular server. Okay, so we are printing the HTTP get code and this %d, then this HTTP code. This %d will be replaced by the code we are getting here in the response. Okay, so there are different type of codes we are getting from the server. One code which is 200 resembles that the link was successfully requested and we got the response successfully. There are many different kind of response codes which is mentioned here. Here is the list of HTTP status code. So each code have a different meaning, like 100, 101. There are many type of codes. Like most common code is this 404, the page not found code, which we generally see on a web browser. That means the request resource could not be found, and you can read this page to get information regarding different kind of codes you're getting in response. Okay, and if it is successfully the link is successfully requested, we'll get this 200 OK response. That's the standard response for successful HTTP request, as I said before. Okay, so I'll be attaching this Wikipedia link in the description so that you can learn about different kind of codes. Moving ahead, we have if HTTP code is equal to HTTP code OK. That means if the response code is 200 OK, then we'll be printing the response from the server. What kind of response, what kind of page we are getting, or what kind of data we are getting from that particular page. Okay, so this will be printed in this a particular section, which will be first saved into payload, and then payload will be printed on the serial monitor. And if it is not 200 OK, if the response is non-negative, means the link was not successfully requested, then we'll be printing error with the particular error code. Okay, so here it will be printing the particular error code, and you can just check out the error code on that Wikipedia page, and you can get to know what the meaning of that particular code. Okay, after that we are just closing that HTTP port, okay, by this function called http.end. And yeah, after a delay of 5 seconds, this whole process is repeated and repeated. So this is it about this basic HTTP client code. Let's just upload this code and see what we are getting on the serial monitor. We'll select the tool we'll select the board from the tools, which is this ESP32 DevKit V1, and on the port I already selected here. So just click on this upload button. I'll press and hold this boot button. And why I'm pressing this boot button, for that you need to watch the first episode of the series. Okay, started uploading, and Okay, it's done uploading. Let's just open the serial monitor, and we need to press this reset button. So I just press the reset button and it says 4, 3, 2, 1, and okay, it's begin and it's requested the link, and we got the code 200, which I already told it's a successful request code. And what we got in this, let's just stop this auto scroll and let's observe what we got in response. So we got a HTML page in response, and as you can see here, it is written as this domain is established to use for illustrative example, which is same mentioned here. So this particular code we are getting in the response on the serial monitor in the form of HTML page. Okay, so if I just go into the inspect or view page source, I think. Okay, so as you can see, this particular code we are getting response on the serial monitor. So the link was requested, the link was successfully requested, and then the server sent the response in this HTML form, and that response we are getting on the serial monitor. So this was all about the basic HTTP client code onto the ESP32 board. Now I will let you know what kind of projects you can make. I already written the code for that particular project. Let's just open the first project, which says Thingspeak Hall effect sensor monitoring HTTP client. Okay, so let me just brief you about this code. This code uses the Thingspeak platform, on which we are sending the data of the inbuilt Hall effect sensor or the magnetic field sensor, which is already built in this ESP32 board. So we are just sending the data of that particular sensor to the Thingspeak server via this HTTP request method. Okay, so I just modified that basic HTTP client code, and with a little modification, I was able to successfully put the data onto their server. So let's just see this code. We need to provide the API key. I am not going to detail about Thingspeak. I will attach a link in the description in which I have gone into detail about Thingspeak server and how we can use Thingspeak. So you can watch out that video. So I will just let you know the important points in this code. So first of all, I'm reading this sensor reading by the function called hall read, so which is stored in this sensor reading integer, and that particular reading is first of all printed on the serial monitor, and after that, using this particular link which contains the sensor reading and the API key, I'm sending the data of the Hall effect sensor to the Thingspeak server, and that's it. This is the little modification I'm done in this particular basic HTTP client code. Let's just upload it and see it in action. Press and hold this boot button, and it's compiling. Okay, it started uploading, and so it's done uploading. Let's open the serial monitor and we'll press this reset button. Okay, so it's 4, 3, 2, 1, and yeah, the sensor value is 6. Now this, okay, it's requested and it's sending to the server, and we got 200. So the value on the server right now must be 6. Let's just observe that. Okay, so as you can see, the Hall effect sensor value is 6. If I bring a magnet close to this particular ESP32 chip or ESP32 board, the sensor value will go about 10 or 12. Let us observe the reading. Let's just press the reset button. I think there's an issue in the connection. Okay, so we are getting the values. It is 22, 28, 25. So last value requested was 25. Okay, it is 25. So let's observe this particular reading on our Thingspeak server. Are we getting this value, or do we get this value 25? Okay, we are getting the value 25. So the link is successfully requested, or the data is successfully written on this onto this particular Thingspeak server, the data of a Hall effect sensor. So yeah, so this is how we can use this basic HTTP client code to monitor the inbuilt or any external sensor data over internet. Okay, so this is it about this particular example. I have made another example which is kind of a IoT button. Pressing the button, we can do multiple tasks. I have assigned one task to this button. So this is the code IFTTT_IoT button HTTP client. Now let's just have a look over this code also. This code also uses the API key, but this time it is using the API key of webhooks. Last time the last code was using the API key of Thingspeak server, so both are different. Okay, I also gone into detail about webhooks and IFTTT in my previous video. I will attach a link for that also in the description. In this particular video, I'll be covering only the important points or the modifications which I made from in the basic HTTP client code. So the event name must be written, or event name is must if we are using this webhooks, and this API key is also must. Okay, so we have to declare this particular strings. Then the link is link for the IFTTT or the webhooks is this maker.iftt.com/trigger/event name, and this API key. Both are variable. It differs with a different user and with a different project. Okay, so what we are doing, if it is successfully connected, we are requesting one link, and this particular link, whenever this particular link is requested to webhooks, it sends signal to IFTTT, and IFTTT sends a notification on my smartphone. Okay, so this is the particular task done by this webhooks service. What kind of projects you can make? You can make like whenever the link is requested, turn on the light. Whenever the link is requested, turn on the music, etc. You can do multiple tasks, or you can assign multiple tasks on the IFTTT using these webhooks. Okay, so in this particular project, I'm just receiving a notification on my smartphone that event button pressed is triggered. Okay, now here I haven't given a condition like if the button is pressed, then request the link. I just forgot to add that particular condition, but no worry, you can add a condition here that if particular button on the ESP32 is pressed, then link the request. If particular sensor reading is above the threshold value, then request this link. So you can assign this kind of task. I think this is very simple, so I don't need to explain this. In this particular code, I'm just requesting a link or after every 10 seconds. That means I'll be getting a notification on my smartphone at an interval of 10 seconds. So let's just upload this code and see everything in action. So I'll click on this upload button. I will press and hold this boot button, and I'll just take out my smartphone. Okay, it started uploading, and uploading, and it's done uploading. We'll open the serial monitor and we'll press this reset button. So it started with 4, 3, 2, 1, and okay, it's requested the link, and congratulations, you have fired a button press event. Okay, so I received a notification on my smartphone. Let me just zoom it in. I think it is visible. It will okay, it's triggering. It's again requested a link. I will receive. Okay, here is the notification from the IFTTT which says the event named button pressed occurred at maker webhooks. So let me just bring a bit closer. So it's again requested, and as you can see here, I received one notification. I also received a notification on my smartwatch which is connected with my phone. So this is how okay, again it is requested. Okay, so it is requesting this particular, let me zoom it out. So this particular board is requesting link every 10 seconds, and hence I'm receiving a notification on my smartphone at an interval of 10 seconds. So this is a basic explanation of the IoT button. You can make different projects using this IoT button, as I already explained, like turning on and off appliances, turning on and off the music, or getting notification on your smartphone with particular date and time. So many projects are possible using this particular IFTTT and using this particular basic HTTP client code. So it's just its name is basic HTTP client, but we can make various advanced level projects using this HTTP client code. So yeah, this is it about the third episode of our ESP32 series. I hope you got the idea of how you can use the HTTP client code on the ESP32 board, how you can modify the ESP8266 code to run onto the ESP32 board. And I also covered the Wi-Fi multi. I also explained you two different kind of projects which you can make using this particular code. I hope you got to know something different which you are not knowing before by watching this particular video. So yeah, ending this video here. Subscribe my channel if you want to learn more about this ESP32 board, and also if you want to learn about the projects regarding IoT automation and electronics. So wait for my next video. Until then, explore, learn, share with me, techiesms.